Welcome back, engineers. Let's continue our discussion on single leader replication systems. So in the previous video, we discussed about different types of replication strategies. We discussed some failovers and we saw what happens when leader fails, follower fails, and so on. Now let's discuss what exactly happens when a replication log is sent, right? So there are different ways to send replication logs from leader to follower. So the first one is statement based. So these are basically raw queries. So the leader sends out queries. So if an insert needs to be made, an insert query is sent in the log like this. So insert into some table and values are given. So the exact raw query is sent as part of the log and the followers execute the query and update themselves, right? So this is one way to do it. But the problem with this is sometimes there can be non-deterministic functions. For example, I want to insert a timestamp which requires to execute the now function from the database. So the now function gives a different value in a leader and a different value in the follower. So this becomes non-deterministic and there is difference of data which leads to inconsistency in the database, right? So this is the challenge with statement-based logging. The second way to do it is data structure-based. So these databases use complex data structures like LSM and B trees. So the logs will send the exact byte sequence of bytes that needs to change internally. So the bytes are taken and those are updated in the followers. So this is one way to do it. But these are very restrictive and very data structure based, and they are tightly coupled with the underlying database. So this is also an option, but something to keep in mind when dealing with this one. And the third one is row based. So in this type of log, instead of queries, the exact values are being sent. For example, the log specifically identifies a particular row inside a database. For example, in table 1, row 1, and I'm going to give you a value for column 1, and which is this. So the followers can go to this particular row in this particular table and update this value. So the exact values in a row in a particular column is given, and the followers just update those particular rows and columns, right? That way there is no issue of non-determinism like this. So the leader can execute the now function and get the latest timestamp and just follow and just forward it to the followers, right? So these are some of the methods of replication logs. Now let's discuss some of the problems with this single leader system. So because we are using asynchronous or semi-synchronous replication, there might be a little lag between replications, right? Because these are servers distributed across different locations maybe, and they're connected over the internet, there is a certain lag between the leader and the follower. So this creates some problems. So let's see some of the problems. So I've taken some photos directly from the book because they've done an excellent job with the diagram. Let's see the first problem. So in this scenario, the user is basically making a comment. So it's an insert query, and this query is taken by the leader. As we know, all writes go through the leader, and the leader is forwarding them to follower 1 and follower 2, right? But because there is some lag in between writing and reading, the same user who has made a comment just now has passed the write to the leader, but he's reading from a follower, right? Because reads come from followers, and the user is not seeing his own comment. So this is the problem of reading your own writes. So the user has made a write request, the leader confirmed that the write is successful, but the user is unable to see the comment, right? So when the user says select star from comments, there are no results. So this is the problem of reading your own writes. So the possible solution for this is the databases provide an option to read from the primary, which is the leader. So for this particular user, if I am the user and I have just made a request to the leader to make some write update, when I'm immediately requesting a read, give it to me from the leader itself, because the leader also has all the data, right? So we can forward the read request also to the leader. In some specific cases, we can apply this logic. Now let's see another issue with replication lag. In this case, the user is again making a comment to the leader, and the leader confirmed that the insert is okay, and the leader is forwarding the request to follower 1 and also follower 2. But in between, so when the second user is reading from follower 1, the result shows that a comment exists. Again, when the user immediately clicks on refresh or something, the read query goes to follower 2 this time, and there are no results. So in this scenario, the time appears to go backward. First, they have seen a comment and then the comment is lost, right? So the user is confused. What happened? So this is the case of monotonic reads. So for the same user, if they're making the same query, first read is going through follower 1, second read is going through follower 2, and this is creating a problem. So the possible solution to this is to use IP hashing, which we have discussed during our load balancer video, right? So for the same user, if they're issuing a query, return them from the same follower. So basically couple this user to a particular read replica and always give results from there, so that there is no issue of time appears to go backward or forward or anything like that, right? So those are monotonic reads. And there's a third issue that is even more trickier, and this involves sharding, right? So let's say there are two people talking and there's a third person observing this conversation. So in this case, Mr. Poons is asking a question: how far into the future can you see Mrs. Cake? And this is going into leader of partition 1. Partition are nothing but shards. So this is going to partition 1, and partition 1 has a follower, and the leader is forwarding the request to the follower, right? And the second user, Mrs. Cake, is answering the question, and this answer is going to partition 2, right? Let's say that is our configuration of the database. So this partition 2 also has another follower, so the log is forwarded to the partition 2. But from the observer point of view, it is possible that the second answer, about 10 seconds usually, Mr. Poons, is appearing before the question itself, right? Because the observer is reading from two different databases, first from partition 2 and maybe then from partition 1 follower. So it may appear that an observer may see the answer before they see the question. So this creates a causality violation. So the answer is appearing before the question itself. So this is a dependency between two different queries going to two different database servers, but they are somehow dependent. So this is one of the trickier problems to solve because it involves multiple partitions, and the queries are actually dependent on each other. One query has to go after the other, right? So this is something we can solve using some kind of versioning system, using vector clocks, and we will discuss all this in some future video, right? But these are some of the issues to keep in mind when discussing single leader replication systems. So these are some of the problems with replication lag when dealing with distributed systems, right? So these are some of the example databases: PostgreSQL, MySQL, and MongoDB. These are some of the modern databases that support single leader replication systems, and they're quite popular because of the simplicity of the setup. There is one leader, there are multiple followers. Leader always takes writes and the followers always take reads most of the time, and this is a very simple setup. Now let's see when to use a single leader replication system. So when you have strong consistency needs, where your write operations are more critical and the sequence of write matters, then you might probably go with single leader replication system, because there is always a single leader taking in the writes, and there's a stronger consistency achieved with this system. So some of the examples can be banking or ERP systems where the transactions are critical in nature, right? So this is where we can use the single leader system. So one of the main benefits of using this single leader replication system is we have achieved great read throughput. So there are multiple followers and they are all contributing towards the read throughput, and we have achieved some kind of load balancing for reading. But what about write throughput? In our single leader replication system, all writes are going through a single leader, and this can create a bottleneck for write heavy systems, right? So how do we handle this? We will add multiple servers that can take in writes, and we will see in the next videos how this topology with multiple write servers and multiple read servers happen. Okay, that's all for this video, guys. I hope you got some understanding of single leader replication. Let me know in the comments below if you have any questions. Do leave a like if you found this helpful. Do subscribe if you haven't done already. Thank you so much for watching. I will see you in the next video. Cheers.